Thank you. So my goal for today's lesson is keep the motivation intact, have the learning objective clarified, make sure students learn more about clean technology and sustainability, and probably tries to teach you something new at the end so that you keep pondering whenever you get a chance in your further career about this. Okay, so hello everyone, my name is Abhishek Soni. So I will be teaching you about green hydrogen, which is kind of continuation from yesterday's lesson, but not completely. And I will be teaching you how you can apply this in your real practical life. All right, so learning objective for today's session is, I have put down two here. First is, why should we or the world care about generating hydrogen from water electrolysis? Why should we bother at all? Second, how can we make it even better? So the situation is that currently 70% of hydrogen is generated from burning of natural gas or fossil fuels, which emits carbon dioxide into the atmosphere. So how the process works? You take the natural gas, heat it at very high temperature in industries, and basically you emit CO2, which nobody wants actually in the atmosphere, because there's a level of global warming every day rising. And then you basically get this hydrogen, which is what I've been teaching about, that this hydrogen can be acted as a fuel. But the problem is this is CO2 is emitting in the atmosphere at the same time. And this is one of the concrete data from NASA, where they reported that from 1880 to 1940, there was actually negative rise in temperature. But look at after that, after 1940, when there is more urbanization, more technology coming into picture, more industrialization, all those kind of things, then basically this temperature, average temperature rises to 0.89 degrees centigrade. And this metric will keep going if we don't try to address this, right? So this is really something very concerning, and we should really focus about that. Why do we want to switch to something alternative of this, right? Because you definitely need this, you can't be avoiding this. So how can you make the process more towards different alternate source of energy which does not emit CO2, correct, in the atmosphere? So here is a thinking activity for you guys, that can you just take a moment, take a pause, and how can you think of any alternative, right? Any alternative which you think of can avoid that process. You can take evidences from my last lesson or any other creative ideas here.
Using water instead of natural gas?
Great. Yes, using water instead of natural gas, that's perfect. And that's why we call it as green hydrogen, right? Because we just need electricity and water, and what we are emitting here? Oxygen, which actually is good for people's survival, right? And what we are creating? Hydrogen, which is what we wanted in the end, right? So that's why there's no CO2 emitting in the atmosphere in this process. And basically, another question to you is now it's clear, and why do we call this as now green hydrogen? Now probably it's very simple, right? Any guesses?
Because it's not emitting CO2.
It's not emitting CO2, correct. So we only need water and electricity to produce hydrogen, fuel, and oxygen without emitting waste CO2 in the atmosphere. That's why it's called green hydrogen. And that is why the world should care about scaling this technology, right? Rather than switching to natural burning of fossil fuel. And this was the learning objective 1 at the beginning. So hopefully we have achieved that. But how do we even go to the greenest hydrogen? So we learned about green. How can we achieve the greenest hydrogen? So if you can make pair of 2 and think for a moment and then come back to it and with some answers, that would be great. This is for
carbon dioxide would be greenest. Green is not sending the emitting carbon dioxide.
Yes.
Greenest would be captured back in
So we're still using natural. Oh.
I don't know, like the green is not, I don't know, what would be the greenest?
All right,
Right.
because of the time constraint, sorry guys, I have to pause here, but any answers which come up, please feel free to share.
The biggest variable is where the electricity comes from, right? Where the energy in your system comes from, right? So it could be on a spectrum of greenness.
So we are using electricity for sure without emitting CO2, but electricity has a cost, right? And it's also increasing day by day. So the vision is to make greenest hydrogen is that electricity can come from either wind, windmills, or solar, or waste heat. For this lesson, I will be focusing on waste heat more importantly, and just to give you a metric or data that more than 60% of global heat is wasted, and we can make use of that waste heat to generate electricity to further power our electrolysis to make greenest hydrogen, right? So I will be taking some time to demonstrate you actually how to use waste heat to produce electricity with just a small device called as thermoelectric peltier, which converts heat into electricity. The price is just $10 US, and it can even go cheaper, like $7 to $6 US. So it's a very cool science experiment, which is this is your peltier device. It has two sides, one this side, and then this is actually a multimeter which can detect the power output coming from this device. So how it works? Right now, if you all can come here quickly, just so that I want to show you very quickly a school experiment. Right now, how much will be the temperature of this and this side? Any guesses? It's in room temperature. Room temperature, right? So if I connect, these are the conductive alligator clips which I was showing in last session. So if I connect this and this here, right? And try to see the voltage. How much is the voltage?
4.
Millivolts, right? And this isn't just ice, right? Ice filled in a glass. If I put it here, the temperature difference increases between the two sides. The volt increases, and the current will also increase. Look at the current. This is the volt. If I switch it to the current, oh no, I have to switch it here, but anyway. But since the voltage is strictly proportional to current, so if I remove, decreased, right? If I put it here, the voltage increases, right? So that's how you generate electricity. And if you connect this wire to your electrolysis cell with the water in it, then it will generate hydrogen and oxygen without even having external power source, right? And it's just $10 US. And people are really trying to scale up this technology where you can produce greenest hydrogen, not just green, right? Without emitting CO2 in the atmosphere. So that's about the learning objective 2. But I did a quick experiment in my lab where I actually connected the water electrolysis. I would like to show you as well. So this is the jar of water with alligator clips, and you can see those bubbles.
So there is a generation of oxygen and hydrogen and splitting of water through thermoelectricity.
This is the bubble, and this is the hot plate.
Electricity,
That's the ice, and there is a thermoelectric peltier there. So I
maintained
connected
at
directly to the
temperature
water
gradient with
electrolysis.
one side ice kept in aluminium foil and other side hot plate. And the voltage you can see started from 2, but as we increased the temperature gradient, it's showing this behavior. Of course, we changed the temperature gradient in between.
So basically, you can really generate the bubbles of hydrogen and oxygen without any external power source coming from the waste heat. So my last learning objective was just to teach you how to generate greenest hydrogen, which I hope we have achieved. But this is a last exercise for you guys, where what should be the plot look like if I have like power output from your thermoelectric device versus the temperature difference between the two sides. What do you think the graph should look like?
Greater power output if there's a greater difference.
Absolutely. So it will be like this, right? So you can do so many things with this thermoelectric device to increase the temperature difference, where you can use it to geothermal plant, where so much waste heat is coming and directly convert water into hydrogen, achieving two goals in the same time, right? All right, so definitely this will be the straight line, and that the power output will increase. And finally, this is the end of my lesson, and hope I have basically taught you about how to apply this into real world scenario. And before ending this lesson, I would like you to think, how can you generate greenest hydrogen on Mars? Thank you so much.